Hey guys, welcome back to lecture series on statistic. So in my today's video, I'm going to explain to you all a measure of a central tendency, which is the fourth part, which is a geometric mean. Okay, yes, I'm going to explain here to you all geometric mean in my today's lecture. If you want to see similar videos, guys, go and check in I button or in my description box. You will get the complete playlist. We already have started entire playlist based on the measurement of central tendency or another topics from the statistic. Okay, so without further ado, let's get into our today's lecture. I'm gonna explain to you all geometric mean for ungrouped data and group data later on. Okay, it is way easier for finding, guys, not that difficult. Okay, it's way easier. Yes, always remember that whenever you have ungrouped data, simple observation or simple data are given. But instead of that, if you get the grouped data, always remember that you will get the class intervals and frequency be there. Okay, must be present. So you have to work accordingly. Okay, yes. So let's get dive into today's lecture. I'm gonna explain to you all for ungrouped data, geometric mean for ungrouped data. Okay, yes. So for ungrouped data, geometric mean, let me explain with the basic concept. You already have learned progression chapter in 11-12 standard, like arithmetic progression, harmonic progression, geometric progression, this type of progression. There you learn geometric mean for two numbers. Okay, yes. So geometric mean, let me explain for the two number. Okay, geometric mean for two numbers. Okay, geometric mean for A and B. I consider A and B are the two number. Okay, yes. So geometric mean for A and B. So we write geometric mean as a square root of AB, A multiplied by B. Okay, so how can we write the geometric mean for the two numbers, which is the square root of A multiplied by B? Okay, that one you learn in your previous class, guys. Okay, that this concept I'm going to apply over here. Okay, so geometric mean for A and B can be written as geometric mean as a square root of A into B. Okay, this is the multiplication between A and B. Okay, yes. So square root means, can we write square root as A multiplied by B to the power 1/2? Okay, this is the way we write geometric mean. Okay, geometric mean as a square root of AB, that means A into B to the power 1/2. Okay, this is the geometric mean for the two numbers A and B. Okay, same concept, guys, same concept I'm going to apply here for the geometric mean. Okay, in our statistic. So this is only for the two numbers. So what happened, instead of a two numbers, we have n number of observation. Now see that we are dealing here statistic, that means maybe n number of data are present. So in such a case, how can we deal? Okay, yes. So instead of AB, let's consider some n number of observation. Okay, so consider we have x1, x2, x3, x4 dash 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 up to the xn. Okay, these are n number of observation we have present over here. Okay, yes. So what is the geometric mean for n number of observation? We write a geometric mean for n number of observation is the square root of these all numbers. That means their power 1/2, like we write x1 multiplied by x2, that means n number are there, na, nth root of AB it is there. Okay, then we write x1 multiplied by x2, okay, multiplied by x3 up to xn, okay, to the power 1 by n. Okay, that means when we have two number, we take 1/2. When we have three number, we take 1 by 3, third root of AB. Okay, yes. So instead of that geometric mean of ABC, okay, if I have A, B, C are the three numbers, their geometric mean we write a third root of A, B and C. That means we write A, B, C to the power 1 by 3. Okay, this is way. Okay, similarly, if we have n number, x1, x2, x3, xn to the power 1 by n. Okay, this is the geometric mean for n observation. Okay, this is the geometric mean for n observation. See that as a power 1 by n, it is quite complicated. It is quite complicated for calculations. So mostly we avoid 1 by n power of these terms, okay? Yes, so that take this 1 by n out from this power, okay? So what is the possible way? We can take log to the both side. If we apply log here, by exponent rule 1 by n come from here, okay? So apply a log to the both side. So apply log to both side. So if you're going to apply log to the both sides, what happen? Log of geometric mean, log of geometric mean. I'm going to apply log to the both sides. Geometric mean, which is equal to log of x1, x2, x3 multiplied by xn, okay, to the power 1 by n, okay. This is the way I applied log here, applied log here. Now it is easier to remove that 1 by n as a power. By exponent rule we can take 1 by n front here. So we write 1 by n log of under bracket x1 multiplied by x2 multiplied by x3 up to xn, okay. This one is the bracket complete. This is the geometric mean, okay, log of geometric mean. So we know that log of a into b. What is the log of a into b? We write log of a plus log of b, okay. Log of a into b written as log a plus log b, but log of a1, a, b, c, d up to n, okay. So we write log x1 plus log x2 plus log x3 plus log xn, okay. So I'm gonna apply here multiplication rule for logarithm, okay. Yes, so take that n as a denominator. We write numerator as log x1 plus log x2 plus log of xn, log of xn divided by n. I written that log x1 to xn this way, okay. Dot dot, n number of terms are there. It is a log of geometric mean, okay, log of geometric mean. So we know that x1, x2, xn, that means some sort of xi repeating, okay. So can we take under series, so it will be easier to remember, okay. So we write series of I is equal to 1 to n log of xi, okay. So see that I is equal to 1 log of xi. So you can replace the value, you will get the numerator here, and which has a denominator n, okay, which has a denominator n, okay. That means n, it is a completely constant term. It doesn't affect for this summation, okay. Yes. So I hope you all have understood log of geometric mean, okay. This is a log of geometric mean that you need to remember, guys. It is way easier to remember, okay. That will be helpful for your finding solution, okay, for geometric mean. Yes, so we want only geometric mean. Now we don't want log of geometric mean. So what we do, take anti-log to the both sides. So log into anti-log, it can be cancelled. So I'm going to write a geometric mean as a anti-log of I is equal to 1 to n log of xi divided by n, okay. This one is our required geometric mean for ungrouped data, okay. See that, guys, it is way easier. That one is very much important here, so mark it important, okay. This one is the very much important, this bracket, okay. This is the geometric mean, okay. Anti-log of I is equal to 1 to n log of xi by n. This is the way we can find the geometric mean for geometric mean, okay. Yes, I hope you all have understood this my entire process for ungrouped data, okay. So for the group data we have similar process. We also have to take some observation where frequency and class intervals are present, okay. That one we consider. Let's get started for the geometric mean for grouped data. I feel that, guys, about the group data we continue it into our next lecture because it is important. So feel like to keep it for the next lecture. In my next video I'm gonna explain to you all geometric mean for the grouped data, okay. For ungrouped data, that's it for our today's lecture, okay. remaining part I'm gonna explain to my next lecture. So till this moment, if you found anything difficult, guys, let me know in my comment section, and if you want similar videos, let me know also. Okay, it encourages me to upload more and more videos, guys, for you all. Okay, for similar video, do check in my description box, or you can check in here in a I button here. Okay, yes. So that's it for our today's lecture. So thank you everyone, thank you for my today's lecture.